Hello, my dear students. This is our third lecture of strength of material. So, till now, we have studied the types of beams, the types of supports, and the probable loads which may act on the span of a beam. So, today, we will study the basic two terms, that is shear force and bending moment on a beam, okay, or in a beam. The shear force is basically denoted by capital V, and bending moment, it is basically denoted by capital M. Okay, so in construction, so what is our basic requirement in a beam? That the beams should be in static equilibrium. So in all construction, the beams are in static equilibrium condition. So static equilibrium condition means the force along all the axes should be equals to 0, means resultant force along all the axes, fx equals to 0, fy equals to 0, fz equals to 0, and at the same time resultant moment with respect to all the axes should be equals to 0. So that is the basic condition of static equilibrium. Okay, so here you can see this is a cantilever beam, so this is the span L. Okay, and with respect to this frame of reference, so this is the beam. So you can find out the coordinates of A, point C, and point B if the probable lengths are given. Okay, so here on the span you can see one point load P is acting at the free end. So this is the free end, this is the fixed end. Okay, and from some point C to point B to the free end, the UDL, okay, uniformly distributed load is acting. So due to this load, so there will be generation of shear force at each of the points, okay, on the beam. So if you follow some procedure, so you can find out the shear force and bending moment value at point B, distinct points B, C, and point A. So on all the points, so you can find out the value of shear force and bending moment. Okay, so what you need to remember, that the resultant force on this beam will be equals to 0, the resultant moment will be equals to 0. So on the basis of these two principle, okay, that is static equilibrium principle, so you can find out the shear force and bending moment at each of the point on a beam. So basically in the problems whatever we will be giving, okay, or whatever we will be given, so at some distinct points, so we need to find out the shear force value and the bending moment value. Okay, so what is this shear force, how they are calculated, and what is bending moment? So we will see by taking the example of the previous let's say the cantilever beam example. Okay, so here the cantilever beam is there, so one end is fixed, other end is free, so the length is L. So you can point this end as A, let's say this is B, so let's say this is C, like the previous beam. So with respect to this coordinate system, so you can take as this reference, or if you want to take this is x equals to 0, then this will be x equals to L, or if you want to start from the right hand side of the beam towards the left hand side, so you can take this equals to 0 and this equals to x equals to L. Okay, so the final thing is that, so the length should be, total length should be L. So you can start from this end or from this end. So one thing here I want to just appeal you to make one note, that for cantilever beam always you consider the right hand side of the beam to be x equals to 0 and the other hand as the final side, that is x equals to L. Okay, so for a cantilever beam always you start from the right hand side and you go to the left hand side to calculate the shear force and the bending moment. Okay, So now what is shear force? How these shear force are calculated? So the definition is that summation of all the transverse forces acting on a beam up to a section. Okay, so these shear force are calculated. The shear force are calculated at sections because the total force, okay, will be equals to 0. That is why the forces will be calculated up to a section only. Up to a section it may not be equals to 0. It will be having some finite value, isn't it? So we will be calculating the shear force up to a section. Okay, the section, this is XX section, I have taken as red mark. Okay, so this section may be anywhere on the beam. Okay, so this X distance, it is taken from X equals to 0 from the free end. So this section may be here also, this section may be here also, or this section may be here, or it may be on the extreme left hand. Okay, so don't get confused. So summation of all the transverse forces acting on a beam up to a section. So these are the basic definitions, and word to word you need to remember this line. Okay. Then what is bending moment? How they are calculated? That summation of moments of all the vertical forces upon a section. So vertical forces, you can see there is a point load. So this is the UDL, uniformly distributed load. Okay. So summation of moments of all the vertical forces. So this is one vertical force. This UDL is also a vertical force. Okay, so it is not necessary that always the loads will be acting from the top side. From the bottom side also there may be some loads. For simply supported beam, so there may be two reactions, okay, from the bottom side of the beam, okay, or the span. Okay, so to understand the shear force, okay, and the bending moment, so let us consider this section XX, okay, in between the point C and point B. So this small segment, okay, this small segment is represented here. So this is the free body diagram of this small segment. So here the load P was acting, so that same load it is acting on this point, you can say point B. Okay, and up to this section the UDL is taken, not the whole UDL I have taken, only up to this section XX the UDL is taken. So intensity of the UDL is W Newton per meter. Per unit length, what is the intensity? W Newton. Okay, so if you want to calculate the bending moment up to this section, means on this section what will be the value of this bending moment, arbitrary section, so you can calculate by this way. So what is the vertical loads? So what are the vertical loads? This P is the vertical load here at this point, and the UDL. So UDL we have seen in the types of forces or loads over the span of a beam. So the UDL will be acting along the centroid. Okay, so the total distance here it is X. So at X by 2 the load will be acting. So what will be the magnitude of the load? W Newton per meter. So this distance is X, so magnitude will be small w into X. Okay, small w into X, that will be capital W. Okay, so it will be acting through this point C. Okay, centroid, this is centroid. So up to this section from right hand side we are moving towards the left hand side. Okay, so now I will not go details to the sign convention of the loads, so I will cover it in the next portion. So you need to remember that on the span of a beam, if you go from right to left hand side of the beam, so all the vertical loads which are acting on the top of a beam, so you are bound to take the loads as positive load. Okay, from the right hand side to the left hand side if you just approach. So at this section, so what are the loads? So one load is P. So what will be the moment if you want to calculate the bending moment? So what will be the value of P? What will be the value of moment? So due to this force, the distance will be x. Okay, so P into x will be the moment, bending moment, because moment is what? Force into perpendicular distance. This is force with respect to this axis, this is the distance. Okay, so P into x is the moment, plus this is the UDL. So what is its magnitude? W into x. So it will be acting through this centroid. Okay, so for this small w into x, I have replaced it by capital W, and distance from this section to the centroid, means to this point, will be x by 2, because here also it will be x by 2. So this will be the moment for this UDL. Okay, W, capital W into x by 2. So P into x will be for point load, and W into x by 2 will be for this UDL. So up to this section, the value of this bending moment will be Px plus W, small wx, W x square by 2. Understood? So my dear students, so in this way, so we have to find out the value of the shear force and bending moment. But here we need to see the sign convention. Okay, so what will be the sign, whether it will be positive or negative if it is acting from the top side of the beam. So we are going to see that thing also. Okay, so let's see the sign convention of a beam. Okay, so we had the idea of the shear stress on the element of a beam, that if the effect is clockwise, then the direction is taken as positive for shear force. Okay, and on the element of a beam, if the effect is anti-clockwise, okay, anti-clockwise direction, then the shear force value is negative. Okay, so that thing we need to follow. Okay, for shear force, so to determine shear force, so we need to follow this sign convention for the forces. I will show you by taking the example of a beam. So let's say this is one element. Element means, let's say this is the beam, so this is one small element. Okay, so these are nothing but the small elements. So what I have said, that one beam will be having one left hand side and the other right hand side. Okay, so if you want to make this x equals to 0 and x equals to L, then you are moving from left hand side to the right hand side of a beam. So if you move from left hand to the right hand side of a beam, the upward loads, okay, the loads which will be upward direction, means like this, if the loads are acting, okay, then you need to take the sign of the load as positive. Okay, from left to right, if you move in if the forces are in upward direction, then the forces will be taken as positive forces. Okay, positive. And the downward forces means which are acting from the top side of the span, so they will be taken as negative. So just you need to remember these drawings. Okay, so from left to right, if you move, if the forces are in downward direction, so it will be negative forces. Okay, negative forces. Similarly, if you move from right to left, okay, from right to left means if this is x equals to 0 and this is x equals to L, if you move from right to left, then upward forces, okay, so upward forces, right to left, if you move, upward forces will be negative and downward forces will be positive. Okay, so let us consider this is a simply supported beam. So I have taken the left hand side as x equals to 0 and this is x equals to L, because the span